This recording will show you how to solve trigonometric questions in right-angled triangles. This topic comes up in both GCSE Foundation and GCSE Higher exam papers. To complete this process, you need to follow a number of steps. Step number 1, you have to label the sides. Each side has to have a name. The side that's opposite the right angle is called the hypotenuse. Label it with the letter H. The side that is opposite to the angle you have worked with is called the opposite side. You're going to label it with the letter O. The third side, which is adjacent to the angle you're working with, which is between the angle you're working with and the right angle triangle, is going to be labeled as A for adjacent. This is step 1 done. Step 2, out of the 3 sides that you have labeled, you will only keep 2 of them, so you need to decide the 2 sides that are required and the side that you are going to ignore. So in this example here, you've been given X and Y on the opposite side and the adjacent side. So these are the 2 that you're going to keep, and therefore you're going to ignore H. So the 2 sides that you're going to keep here are O and A. Step 3, as you have identified the 2 sides you're working with, which in these examples are O and A, you can now decide which of the 3 trigonometric ratios you're going to be working with. Are you going to be working with SOH, COH or TOA? Well, because you have eliminated the H, you can cross out already the ratios that involve H. So the one that is left is TOA. So the trigonometric ratio that you're going to need to work with is going to be TOA. Step 4 is a very important, essential step, because all the work you have done so far is preparation work to write the equation. Now here you're going to form the trigonometric equation, and in an exam question, this is where you get your first mark for a correct trigonometric equation. We have identified that we're going to be working with TOA. So the equation will be, the T of TOA stands for tan. So we're going to do tan of the angle from the triangle, which in this case is the Greek letter theta, equals, well, it's going to be equals to a fraction. The numerator is going to be O, in this case x, and the denominator is going to be y, which is the adjacent side. And this is where you're going to gain your first mark. Now, what's going to come next, the final step, step 5, is where you're going to actually answer the question and find your final answer. And it comes into 2 very possible ways, so 2 twists on them. Twist number 1, you can be asked to find a side. If you need to find a side, then you are going to need to solve your trigonometric equation. So, for example, if you want to find O, the opposite side, we're going to start from this equation we wrote above. So tan of theta equals x over y. And if you want to find the opposite side, you want to find x. And you're going to solve your trigonometric equation by clearing the denominator. If you want x alone, then you will need to multiply both sides by y. The y is eliminated. You now have x equals y times tan of theta. If you are asked to find y instead, your rearranging would just be a little bit trickier. If you wanted to find the adjacent side, then you would start from the same equation, the one that gets you your first mark, tan of theta equals x over y, and you also have an equation to solve here. The problem is that y is a denominator. So you're going to start by multiplying both sides by y, which means you now have on the right hand side just x, and on the left hand side y tan theta. And your second step will be to divide by tan theta. Divide both sides by tan theta. The tan theta is cancelled, and you're left with y equals x over tan theta. This is where you get your second mark. The second possibility is they might be asking you to calculate the value of a missing angle. Here again, you start from the same equation, the one that got you a mark. So this is tan e of theta equals x over y. But this time you want to undo the effect of tan. And to do that, you're going to need to apply for each side the function that can be found on your calculator, which is tan minus 1. So on the left-hand side and on the right-hand side, you're going to cancel tan by doing tan minus 1. On the left-hand side, the tans are cancelled, you're left with theta. And on the right-hand side, you now have tan minus 1, and the argument you're going to put within tan minus 1 is going to be x over y. So this process is completing following these 5 steps. On the next slide, you are going to find 4 questions that you can try, and then the worked solution. Here are 4 typical examples that you can try now. So pause the video, have a go. The answers are on the slides as well. And then the next few slides will show you some worked solutions. Here is the worked solution for the first question. You always follow the same steps. Opposite the right angle, you will find the hypotenuse labeled as H. Opposite the angle you're given, you're going to find the opposite sides. The third side, if you wish to label it, will be A. Step 2, you need to keep 2 sides. We're going to need H because we know H. We're going to need O because we want to calculate O. So the side that we are going to get rid of is going to be A. So we've got O plus H to work with. Step 3, you need to select which one of the 3 trigonometric ratio you're going to keep. The 3 trigonometric ratio are SOH, COH, and TOA. Well, I got rid of the A, I'm working with the O and the H. So if I don't have the A, I can't work with TOA, I can't work with COH, I'm going to have to work with SOH. So now I'm going to write the equation, which is where I get my first mark. S stands for sine, so sine bracket 18 degrees, because the angle is 18, equals O over H, which is 10. So O is the lowercase letter a, and H is 10 centimeters. This is where I'm going to get my first method mark. The second step here is I'm going to need to rearrange the equation in order to find the value of the little letter a. I'm going to solve the equation because at this point in time I'm no longer doing geometry, really all I'm doing is I'm rearranging an equation, I'm doing some algebra. So a is divided by 10, I'm going to multiply both sides by 10. This means that on the right hand side the denominator has been cancelled, I'm left with a. On the left hand side I now have 10 times sine 18, and that might look a little bit confusing, but sine 18 is just a decimal. It's a very long decimal, but that's all what it is a number. Pick up your calculator, type 10 multiplied by sine 18, close your bracket, and you should get a equals 3.1 centimeters. Example number 2. The steps are always the same. We've got a right angle. Opposite the right angle is the hypotenuse. We've got the angle of 35 degrees we're working with. Opposite the angle of 35 is O. And your third angle, the third side, will be A. That's step 1 done. Then I need to keep 2 sides. Well, I'm going to have to keep A because I know the value of A, and I'm going to have to keep H because that's my unknown. That's the side I'm trying to find. So I'm going to ignore O. Step 3, out of my 3 possible trigonometric ratios, SOH COH TOA, I need to decide which one I want to keep. Well, if I have dropped O, then I can't use SOH, and I can't use TOA, I have to use COH. Now I am going to form the equation, and this is where I get my first mark. So I always need to write this equation. And the equation will be written is I start with a C, which is cos, the angle is 35 degrees, equals, and then cos is K, so it's A, over H. A is 4.5 centimeters, and H is B. At that point, once again, I am no longer doing geometry, I'm actually solving an equation. It's a little bit trickier because this time I've got the unknown at the denominator. So the first step is you're going to clear your denominator, you're going to multiply both sides by b so that you no longer have the unknown at the denominator. So the result of multiplying both sides by b is that on the on the right hand side the b's are cancelled. I now have what's left is 4.5, and on the left hand side I have b multiplied by cos 35. And I like to put the trigonometric ratio at the back so that I have the brackets are closed, everything is clear. Now I want to find the value of b, and at the moment I've got b that is multiplied by cos 35. So my next step is going to be to divide by cos 35, and whatever I do to the left, I have to do the same thing to the right. The result of this is that the two cos 35's cancel on the left hand side. I'm left with b equals 4.5 over cos 35. So by the way, the first mark you got was for writing your equation, and now you pick up your calculator and you work out your result. You should get 5.5 centimeters. Example number 3. Same method as before. You do it step by step. Step number 1, label the sides. You've got the right angle. Opposite the right angle is the side called the hypotenuse. You label it with H. So you find now your angle C, which this time is not on the right hand side but the left hand side. So watch out. This means that the opposite side will be where the 7 is. And then finally your third side, if it helps you to write it out, then do. It's A. Step number 2, you need to keep two sides. Well, you're going to keep H because you know its value. And you're going to keep O because you also know its value. A is pointless, so we're going to get rid of A. Step number 3, out of your 3 trigonometric ratio, you're going to choose to keep 1. How do I select? Well, I need the one that doesn't use A because I've removed A, I've eliminated A. So I can't use K, I can't use TOA, I'm going to need to use SO. I'm now ready to write my equation, which is going to be sine of the angle, but this time we don't know the angle, so we need to write the letter in the angles, the space within a sign. So sine of C equals O, which is 7, over H, which is 11. And this time it's a little bit trickier because we basically need to get the value of C, the value of the angle, knowing sine C. So we need to undo the effect of sine. And to do so, again it's a form of equation because whatever I do to the left, I do the same to the right. If I want to undo sine, then I need to use the function on my calculator, which is written on calculator as sine minus 1, just for information. It's called arcsine, you don't need to worry about that. So I'm going to need to do sine minus 1 on each side. If I do it on the left hand side, then I have to do the same thing on the right hand side. You can access this sine minus 1 function by using shifts and then sine minus 1. You will find it above the sine button in yellow, in gold. Right, so what happens if I apply sine minus 1 on both sides? Well, sine and sine minus 1 are inverse operations of each other. So this means that on the left hand side, I'm left with C. And on the right hand side, well, I'm going to apply sine minus 1 to what? To 7 over 11. Now you pick up your calculator, you type sine minus 1, 7 over 11, close the brackets, and your calculator should give you the answer of 39.5. And this is where you're going to get your marks. Your first mark is always for writing the correct equation, and then you will get a second mark for working out the actual angle. final example here, you should have a practice hopefully by now. Step number 1, label the sides. So we've got the right angle, therefore I can find the hypotenuse opposite the right angle. Then I have got an angle of 70 degrees, opposite to the 70 degrees, I'm going to label O. And then on the sides, I'm going to put the letter A. Step number 2, I only keep 2 out of these 3. Well, I need to keep 41, because I know it, and I need to keep D, the adjacent, because that's what I'm trying to calculate. So I'm going to drop H, which means I can start step number 3 and choose between the 3 trigonometric ratios SOH COH TOA. And I have dropped H. I'm working with O and A. So this means I can't use SO and I can't use CA. I'm going to use TOA. We're now reaching step 4, which is where you get your first marks. A very important step. To write TOA, this means that we are writing tan of the angle equals opposite, which is 41, over adjacent, which is D. And this is one of the example of a trickier setup when D is at the denominator. So the first thing you do is you actually need to clear the denominator so that you no longer have the unknown at the denominator. So you're going to multiply both sides by D, which has the effect on the right hand side of cancelling the denominators. On the right hand side you are left now with 41, and the left hand side you've got T, D multiplied by tan 70. Tan 70 is just a number, so in the same way as if you had D times 4 or whatever easy number you're more used to in algebra, you are going to divide by this value. So you're going to divide by tan 70, and whatever you do to the left you do the same to the right, which means that now what is left, well, the tan 70 on the left hand side have cancelled, so you're left with D on its own, and on the right hand side you have 41 over tan of 70. You pick up your calculator and you type 41 over tan 70, be careful to close the bracket, and you should get a value of 14.9. And you are now ready to do a little bit more practice on your own if you feel the need for it. Good job, guys.